All right, so we're going to go over the last exponent rule, which is when you have fractions. So we have fractions to exponents. So as you can see here, it says when a fraction is taken to a power, the power must go to both the numerator and the denominator. And so what that would look like is we're going to treat the numerator and denominator separately. So we're going to say, okay, there's the numerator, 3x. We're going to bring the power of 2 to the numerator, and we're going to bring the power to the denominator. So this 2, again, gets distributed everywhere in the numerator. So that would be goes to the 3, goes to the x, and then also to the denominator, which means goes to the 3. So you can see that we would result in the same thing here. So this is going to be a 9x to the power of 2 in the top, and a y to the power of 6 in the bottom. And then after that point, you would simplify what's left here. And so if this expression could be simplified further, meaning if we had multiple bases, so if we had an x on top and an x on bottom, or we had some numbers out front, or we had negative exponents, we would take this another step further and simplify. But this expression is simplified, so we are good there. One more example. So we're just going to do 2 today. I didn't want to do that. Okay, so here is the second example. And you really can do these in 2 ways. So the first way is take the fraction that's in the parentheses and you can simplify it first and then deal with your exponent. But I would rather do it the other way. So I'd rather bring this exponent in, get rid of this bulky parenthesis looking stuff. So get rid of all that and then do my simplification steps after that. So that's the way I'm going to do it. So we're going to go ahead, and this power of 2 is going to go to everything, so that includes this coefficient of 3. So 3 squared would be 9, and then we're going to multiply all of our exponents here because this is our power to a power rule. So we get a -4 and a +6 for my y, and then again, this exponent also goes everywhere down here, so it goes right there to the 2. So 2 to the power of 2 is 4, and then the 2 also goes to this exponent as well, and this is still power to a power rule, so that would be a 14. Okay, so that's my first step. That's my new step. Once I've completed that, now I can go through with the next rule. And so the next rule that I would use would be, are there still powers to powers? The answer is no, that's gone. And so now I'm going to do my quotient rule. So I'm going to first start with 9 over 4. 9 divided by 4 does not simplify to anything better than 9 divided by 4, and so we're going to leave that there. Our x, there's an x on top, there's no x's on bottom, so I would be basically picturing there being 0 down here. Okay, and so my exponents would be x to the -4 minus 0 is still -4, and we know that negative exponents need to be fixed by moving them to the opposite side and changing their exponent to a positive. And so this x to the power of -4 is going to jump to the denominator and is going to be turned into a +4. And then the y's, so y to the power of 6, y to the power of 14 on the bottom, our quotient rule says to subtract those. So I'm going to do 6 minus 14. That comes out to a -8. Okay, and so my answer would be y to the -8. I could write that here. I could write y to the -8 here, but I wouldn't want to do that because I would then have to take another step to simplify that y to the -8. So instead of doing that, instead of just writing y to the -8, I'm going to go ahead and put the y in its appropriate location, which is the denominator, and then I'm going to get to change it to a positive. All right, so I kind of did 2 steps in one. 6 minus 14 was a -8. The -8 told me that I need to write that in the denominator. And that is going to conclude this video, I believe. Actually, let's do one more question here, and let's have you guys work on this. How about 4 over 2? How about x -3, x 5, y 2, y -3, and then all of this to the power of, let's do a 3. There we go. So there's a good example for you. So go ahead, take your time to work on this on your own, and then I will come back and give you the correct answer here in a second. All right, so let's go ahead and do this one together. 4 to the power of 3 is 64. So we're going to bring this power of 3 in. We get x to the power of negative 9 by multiplying. And then we would multiply our 2 times our 3 to get a 6. So that's our top. We're going to go ahead and bring our power of 3 into the denominator. So 2 to the power of 3 is 8. X to the power of 5 multiplied by 3 would be 15. And then my y to the negative 3 times 3 would be y to the negative 9. And then I would go ahead and I would take a second to go ahead and simplify this last part. Okay, so what would that look like? I'm going to divide. So 64 divided by 8 is an 8. That's great. That 8's going to stay up on top. My x's, negative 9 minus 15 is negative 24. That negative tells me that I need to write those on the denominator. So I'm going to move them down, call them a positive 24. And then my y's, got to be careful here. We're going to end up subtracting a negative 6 minus negative 9 is positive 15. And so since that's a positive exponent, I get to go ahead and write that on the numerator. And that's going to be your answer. So hopefully you got that one right. That's it. Thanks for watching. Like and subscribe.